So my name is Jason Turner, just in case you haven't been to any of my other talks this week. Co-host of CppCast, host of C++ Weekly. I've got a few projects that I work on, and I'm Microsoft MVP. I am independent, available for contracting and training. This is what I do, and this kind of represents what my training days look like, although in a different scale, of course. By the way, who here is local to Denver? Okay. Who still needs to come to the meetup because you've never been before? Okay. So that's the name of it. I've had a bunch of people ask me after other sessions. It's the North Denver Metro C++ meetup. For whatever reason, the search engine on meetup.com is terrible. If you type that in, you probably won't find the meetup, even though that's the exact name of it, but Google will get you there pretty quickly. We do meet every month and have since November 2016. So even though I know many of you have been in my talks in the past, you still sat in the back row. Feel free to take a moment and shift yourselves more forward if you want to. Interrupt me, ask questions, yell out. There's a good chance I'll end up in the middle of the aisles again today. We'll see what happens. I do still have one training class. There's still time to sign up for my Const Expert class. It is tomorrow. If for some reason the website won't let you, let me know, and I'll talk to John. Okay, so great C++ is trivial. I am asking the question at the moment, what do we mean by great? Easier to write, easier to maintain, more optimizable. I'm going to touch a little bit on each of these things, but really, for the most part, this session is talking about code that is great in that we're helping the compiler optimize our code. This is not a best practices talk per se. Most of the time when I speak, I'm saying you should always do this or never do this kind of thing. This is mostly to make you think about the way you write your classes. And I'm going to build a little bit on the things that I discussed on Tuesday. It is not meant as a direct continuation. Who is here for what was the name of that talk? C++ Code Smells. Who came to that one? Oh, wow. Well, thanks for coming back. I must not have done a terrible job. Okay. We're going to go through some exercises, as I like to do. We're going to see how quickly or slowly we go through them. Honestly, I don't really know how this is going to go because it's hard to practice this kind of thing with yourself. So we have 4 options here, and I am going to ask you which of these is the optimal design. Of the 4 choices, which one is going to give us the best, most efficient code? Okay, so let's do it by poll. I heard yets of B's. Who says A? Who says B? Who says C? And who says D? Okay. So what do we got? With A, we are forcing a move. We're not allowing return value optimization to take place. With B, we get return value optimization, move elision. With C, what do we have? Wait, what was that? Oh, sorry, I can't help myself. I have no idea why the stage is there. It's not for me. What did you say? Someone's yelled something. What? No compile error. No, actually, it's going to silently revert to a copy unless you've got like clang tidy or something amped up on here. Unfortunately, silently revert to a copy. Okay, so that's a copy, and then D is return value optimization again. Something like that. So I highlighted the ones that are good. Should I have highlighted the bad ones or the good ones? Good ones, okay. So I highlighted the good ones. Good, because that's what I did. I have changed things up a bit. I am using a structured binding from C++ 17. It says get string pair. Let's assume that the undefined function does in fact do what it claims to do. It is returning a pair of strings. Reference. Someone hopes it's B. Hope and wishes. Wait, how's that? I don't have a good, okay. Wait, no, I'm getting hand signals down here. Okay, this could be fun because, again, I am breaking the rules with the stage. What is A gonna do? It's gonna force a move. Okay, what is gonna happen with B? Who says RVO is gonna apply here? Oh, see, now you're not gonna raise your hands because Marshall says RVO is gonna happen. Okay. With a structured binding, I don't have any actual slides explaining this. With a structured binding, RVO can't happen here because str1 and str2 are actually references that point back into a hidden object called E, defined by the standard, which is the actual location where the result from the function call lives. Yay. So B is a copy. What does C do? Well, actually, let's come back to C. Does anyone know that they know for sure what C is going to do? Ooh, okay, yes. What is it going to do?
I give a guess because I'm brave.
Okay.
Lifetime extension by reference value to the synthesized object that you return from get pair.
Yes.
And then str1, I have no clue, might be a R value reference.
Okay, so lifetime extension because it's because of R value reference to the temporary that was returned by get string pair. Yes, and then what happens after that? That's still the question, basically. Okay, let's come back to that one. D. It has to be a copy because it's a const value again. Just for the record, I don't believe you would get warnings from anything except maybe static analysis tools here. And then E. Here, what does E do? Same as B. E is the same as B. It's a copy. That's what I heard up here. By the way, for those of you who did not pay attention and sat further in the back, if you want to participate more, you have to yell loudly or somehow convince me to walk down the aisle or run up to one of these microphones or something like that. Okay. All right, so we got a forced move on A, an accidental copy on B, C. Let's get back to C. D is a copy, even though it looks like a move, and E is a copy. So at the moment, the only thing that we know is a move is A. And return value optimization doesn't apply to any of these. The reason I'm saying on C is there's this paper that was approved for C++20 that is more implicit moves. Is David Stone in the room by any chance? Okay. Because I believe he is the author or co-author of that paper, and I was hoping I might get an answer to this question. With that paper, if you've got an R value reference and you return it, then it's supposed to be implicitly a move now. But will it count an R value reference of a structured binding as an implicit move? I have absolutely no idea. I know there's several members of the committee like sitting in this general area or people who attend meetings. Do you have any idea? No idea, no idea? Okay, great. We don't have any idea. None of the compilers implement the more explicit moves yet, so I can't even test it. Otherwise I would have. Okay, so we didn't learn anything, except we learned that structured bindings mess with our notions here. This is, a little bit coming back to Tuesday. We don't know what useString does. We don't know anything about its function signature. We can still make some assumptions about this code. Tell me, who prefers A? Who prefers B? Who prefers C? Okay, that's the bulk of the room. Who prefers D? I prefer D, just for the record. From an efficiency standpoint, whatever needs to happen, whatever that parameter is that useString is using, it's going to be constructed in place. We've return value optimization, whatever is going to come into play on C or D. We're going to construct that in place. B, we're forcing a move, which, well, we're getting a move, I guess we should say, or maybe a move, I don't know. If useString takes a const reference, then B's just wasted code, and it makes us wonder on line 4, right here, what in the world is the state of string? Has it been moved from? Why did I put this in my mental queue of things that I have to deal with when I read this code? Oops. Knock over the clock. Okay. And A is whatever. It might be a copy, it might be a reference. We don't know. I'm going to prefer C or D from, without knowing anything else about the code. Marshall.
So you said you don't know anything about what useString does.
Yes.
useString takes a string by an on-const rel. C is not going to work at all.
If useString takes, oh, that's true. So Marshall said if the string takes a if useString and block C takes a non-const reference to a string, then the code won't compile. So I guess for the sake of this example, we have to assume that the samples compile, and it's not doing that. But it's a very good point, really. Now, I just out of curiosity, would it work on D if useString takes a non-const reference? Go ahead, Peter. If getString returns a non-const reference, it's the only case in which D would work if the function parameter took a non-const reference to string. That sounds right, yeah. Okay. So we were reasoning about what we're asking the compiler to do at run, or what's going to happen at runtime here. Out parameters versus return values. We spent some time on this on Tuesday as well, definitely. Who prefers A? I have no problem with A. Who prefers B? Yeah, we like B, const as many things as we can. Who prefers C? All right, and then D. D can't compile, really. That was just there to throw you out. What? Yeah, use const cast. Let's invoke undefined behavior. That's a good idea. Maybe I should do a talk, undefined behavior, all the things. Okay, so on C, I just want to point out, we are requiring the compiler to default construct this before we pass it in on line 3, right? It has to do extra work compared to the options on A and B, where we can take advantage of just capturing that thing that was returned to us. Yeah? Can the compiler just what? On option C? No, the compiler can't fix this. You might see examples. You can go on Godbolt or Compile Explorer, Mac Compile Explorer, whatever. Yeah, he's over there, just for the record. Everyone look at Matt. No, I'm just kidding. Sorry. That's what happens when I have too much flexibility. You can construct examples where the compiler would optimize that version away. In the general case, we can't assume that. We have to assume that it has to default construct that string and then pass it in and then assign the value to it. It's only going to be able to optimize it away if the implementation of getValue is visible to the compiler, or you do link time optimization, perhaps. All right. Assignment versus initialization. I am probably moving slow. It's fine. Okay. Go ahead, just yell out something. What do we like? Is that the same code? Nah. Okay, so what are the problems? Let's see. On B, potential problem? Yeah, well, in B, let's see, yes, we construct it, and then we have to do an assignment, same thing as A, but we also get an extra problem on B, special problem, bonus problem. It's a const return value, so now we're doing a copy assignment instead of a move assignment. But C and D avoid those problems altogether. It's another question of default initializing the thing first. Reassignment of values. Who prefers A? Who's going to say A is better, more efficient code? More efficient code, really, Richard? Sorry. Since you're in the front row and I know your name, it's not, okay. So in my talk on Monday, I had Jan get up on the stage with me, if any of you were here for that, although it was in a different room. We were talking about return value optimization being, basically neither a copy nor a move comes into play in guaranteed copy illusion kind of rules. If the object val is here in the second block, then I don't have to do an assignment. I'm just giving a name to the temporary that had to be returned from the function in the first place. And in block A, I have to do an assignment operation each time. It's going to be more work. If the scope is only for that, if I only care about it in that scope. Okay. Point of this talk was great C++ is trivial. Let's talk about triviality. Oh, okay, I'm sorry. I have to do the disclaimer here. I have lots of quotes from the standard. I'm sorry. We'll see how it goes. Is trivially destructible. This is if it is destructible and it is a non-class type or a class type with a trivial destructor. That is what this is saying. Is this trivially destructible? Yes, clearly nothing has to happen in its destructor. Is this trivially destructible? Oh, I heard like a very loud yes. Who did that? You know what? I've been carrying this around for a few days, so you get to have it now. All right. All right, so if the implicitly defaulted destructor would have been trivial, then the explicitly defaulted destructor is trivial. Okay, good, that's trivially destructible. Whew. Is this trivially destructible? No, we gave it a destructor. Does it do anything? No, but it's still not trivial. Not trivially destructible, so the static asserts here are just theoretically proving these things. Is this trivially destructible? No, why not? Because string is not trivially destructible. That was the general murmur. Yeah, okay. String is not trivially destructible. A trivially copyable type, this is where things get fun. If the underlying bytes making up the object can be copied into an array of car, unsigned car, or byte, if the content of that array is copied back into the object shall subsequently hold its original value. So it's something that we can copy the bytes around. Has at least one eligible copy constructor, move constructor, copy assignment operator, or move assignment operator, where each eligible thing is trivial and it has a trivial non-deleted destructor. Who has ever deleted their destructor? Why? Why? Well, no, I'm gonna, since I just gave you yeah, why did you delete your destructor?
Testing concepts.
Testing concepts. Okay, so not in production code. For some reason I have the, not in production code either? Just to show off, okay. Who programs in C++ mostly because they like showing off? Okay. Just for the record, if you delete your destructor, it is valid code. You can new an object, put it on the heap, and then never clean it up in the lifetime of the program. You can write valid code with objects that have had the destructor deleted. It's a very strange thing to do. Okay. Is this trivially copyable? I put the precondition up there that int is trivially copyable. Yes, and then I have another static assert down here. string is not trivially copyable. Is this trivially copyable? No, because it has a non-trivial destructor. Okay, trivial constructibility. Let's see, is known to call no operation that is trivial. So during its construction, it has to call no operation that is trivial. Wait, what did I say that wrong? It has to call no operation, it is known to call no operation that is not trivial. I feel like they could have removed at least one of those negatives somehow and cleaned up the sentence. We cannot call non-trivial operations during construction. That's what we're going for. So this thing, this struct s, with an integer in it and an explicitly defaulted default constructor, it is trivially constructible. Now I'm gonna, let's see if I can, no, I can't do that, never mind. I'm gonna use the wireless mouse. So right here, is trivially constructible. This is the type trivially constructible with no parameters. This is equivalent to the default constructor. That is true. It is also trivially constructible with a copy of itself. It's trivially copyable copy constructible, or not of itself of the same type. If I try to call a non-existent constructor, one that takes two integers, then this is false because it can't be constructed at all with two integers. And if I try to pass it one integer, it is also not trivially constructible because this constructor exists. It doesn't matter that the constructor does nothing. And just for the record, these are all tested compiles. So the fact that I declared a constructor that takes an integer means it is not trivially constructible from an integer. Is trivially default constructible? It's this, it's that base case, the one on line 10. If that's true, then it's trivially default constructible. This is trivially default constructible. And yeah, so that is the equivalence here. Nope, I'm already getting nopes. Nope, nope, not trivially default constructible because we defined a default constructor. Is this trivially default constructible? This is where it gets fun, in my opinion. Who says, yes, this is trivially default constructible? Who says, no, this is not trivially default constructible? Right. Wait, Richard, you rose your hand on the second one? Why not? I'm already picking on you. Why is it not trivially default constructible? I don't think your logic followed, so I'm not going to bother repeating it for the camera. I'm sorry. Just for the record, for YouTube and for the room, I've known Richard for, what, 5 years now or something? So, I mean, I give him a hard time a little bit. It's okay. Yeah, okay. No, actually, more correctly, I didn't fully understand your logic. What happens if I default construct an object of this type? The member gets value initialized to 0. What happens if those braces aren't there? Nothing. It's whatever memory was there. It's undefined behavior to read that value because it's an uninitialized value. This is initializing it. It's like the compiler synthesized a default constructor for us that mem sets this value to 0. So this is not trivially default constructible. Okay, so if I remove those braces, it is now trivially default constructible again. Difference between a constructor that does something and a constructor that does not do something. Is trivially copy constructible? That's just if is trivially constructible with itself. So yes, this thing is trivially copy constructible. Oops. This one is not trivially copy constructible simply because standard string is not trivially copy constructible. Now, who's going to go and make a poster with all of the type traits about triviality after this? Oh. Maybe I should put one up on, anyhow. Okay, string is not. Is this trivially copy constructible? You're raising your hands, yes. Okay, who says yes, this is trivially copy constructible? Okay, does anyone want to make an argument for why it is not trivially copy constructible? Okay, so it is trivially copy constructible. We can copy the bytes back and forth. Its default constructibility does not affect copy constructibility. Is trivially move constructible? Trivially move constructible? Yes. Trivially move constructible? No. String has to do something on a move. Is trivially assignable? It says it's known to call no operation that is not trivial. Is this trivially assignable, and in what ways? We have options. Is it trivially copy assignable? Is it trivially move assignable? Is it trivially assignable from an integer? No. Even though it's just an integer and all I'm doing is copying that value of an integer over, this is not trivially copy assignable from an integer. So we have them broken out here. We can call things that don't exist and make no sense, and we'll get the proper response from our, compile time, static assertion, copy assignment, and user-defined assignment operator is simply not trivial, no matter what's in it. Is trivially copy assignable? It's just a shorthand for calling this is trivially assignable with a t reference and a const t reference. It's what we've already been looking at. So this is trivially copy assignable. No, we've got a string in here. It's not trivially copy assignable. Trivially move assignable, again, it's shorthand. Is trivially move assignable? Yeah, we see a pattern? No, okay. String is not. All right. Get back to something a little bit more interesting. Is trivial. Scalar types, trivial class types, arrays of types of such types, and CV. What does CV mean? Const or volatile qualified versions of these types are collectively called trivial types. A trivial class is a class that is trivially copyable and has one or more eligible default constructors, all of which are trivial. I find this note interesting. I have a theory, I've yet to prove it, but I think that if you were to remove all of the standard and leave only the notes and examples, there would be a lot to learn from just reading those. Like, forget what the standard says, just read the notes and examples. So this little note. In particular, a trivially copyable or trivial class does not have virtual functions. I'm not 100% sure why that rule is true. Peter is, wait, no, let's see. Yeah. Okay, because we have to stamp out the vtable pointer in the copy operation, it is not trivial. Is that what you said? Okay, so initializing an object of that type requires work to be done because of the vtable pointer. Oh, that makes sense. Okay. So, is this a trivial type? I mean, I have the static asserts there. Yes, it's a trivial type. It's not a trivial type. It doesn't have a trivial default constructor, but it is trivially destructible. Okay. Is this a trivial type? No. It is still trivially destructible and not trivially default constructible and is not trivial. Okay, so I went from moving slower than I expected to faster than I expected, so here we are. Which of these versions is most efficient and why? I'm just talking efficiency at the moment. Okay, I'm just letting some people read the code just for the record because I actually see eyes looking up at the screen. B and D. Oh. So because int is a trivial type, they're all going to boil down to the exact same assembly. This is what the answer is I just got. And I am going to agree with that statement. They're trivially copyable, trivial movable. Is it a copy? Is it a move? Does it have to whatever? It doesn't matter. They're all going to fit in a register easy on any platform. No? Oh no, they wouldn't fit in a single register in an AVR, would they? Because int is 16 bits, it's an 8-bit. I think that's... It has to be efficient? Yeah.
That's why you can change the size.
Oh, int, you're saying? Yes, yeah, int has to be efficient, although it has to be at least 16 bits, I believe. I think that's right. So on an 8-bit platform, it still isn't going to fit in a single register necessarily. So yeah, like int is the efficient word size of the system, except when it's not, or something. So return by value. I say irrelevant. Int is trivially copyable and movable. What happens if I disable optimizations on this code? What happens if I build this with O0? Ooh, okay. Ooh, I've angered the speakers in the past. I might, yes, what are you going to say? Yeah, okay. So for the sake of you who couldn't hear that, let's just go ahead and compile this. This compiles to move 5, EAX, comma 5. We're moving 5 into the register EAX. This is the return value from a function, returning an integer on Intel platform. Okay, I'm going to disable optimizations here, O0. The code still had to, the compiler still had to actually generate a call to standard move. It had to. We told it to. We called a function. All right, so let's go ahead and take out move. And it becomes more what we would expect, a little bit of stack handling and then move 5 into EAX, basically. So it's not 100% the same, depending on what build level we're using. That's what I just did. Okay. I am using my structured bindings with my integer pairs now instead of string pairs. What? How's my pair implemented? I'm assuming it stood pair. Okay. All right, so, I mean, based off of what we just learned, who says what? I don't know. How do I even do this? Because at this point, we're assuming multiple answers are correct, right? Probably. B and D? No, I fixed those slides. I fixed them during Tony Van Eerde's talk. I must not have reloaded my presentation. Now I'm going to risk doing this. Let's see. I must have missed a couple of cases. I'm sorry. Okay, let's assume they compile. We're returning int 1. I can't easily edit it right here live. Okay, so A and C in a debug build are going to generate these calls to move. Probably no way around that. B and D, copying some bits around. They're going to be the same. In an optimized build, they're all the same. Now I start putting in asterisks here, irrelevant asterisks. We'll come back to that asterisk in a moment. Pass by value versus pass by move. Oh man, C doesn't compile too. Dag nabbit. Somebody reboot Jason. No, I did not just crash. I was just staring at the code. It's probably non-obvious to the YouTube viewers on camera that there's a monitor right here that I can see the slides on. I had not just like shut down. I was staring at the monitor. Okay, all right. So we're passing these things by move or by value. Now, to make a point that Marshall, I believe, brought up earlier with the string, A and B A will compile if use int is expecting an int reference. But if it's expecting an int by copy or const reference, these are just going to be the same thing again, right? It doesn't matter now. Yeah? In a debug build, A would create a local variable where C would not. It still has to create local stack space for it in either case in a debug build. So if we want to go down this road, let's forward declare the function, and that's there. Okay. So I set up space for it. I save the value 5 here on the stack, pass that in. All right. And we're comparing that to this version. Okay, yeah. I have other examples that'll come back to similar, but I didn't see that particular issue. Okay, so again, irrelevant, asterisks. Int is trivially copyable and movable. Out parameter versus return value. This one I was just having fun with, and I really hope I have the correct version of my slides up right now, and if I don't now, I'm going to fix it. I know I changed, wait a minute. All right, well, whatever I have is what I have now. I know I've built the latest version. Okay. Thoughts? I know the next slide said largely irrelevant again, but so we're, well, okay, let's come back to it. No, all right, stop. We'll stay here. I have a clearly well-defined plan at the moment, right? How many parameters do these functions take? They all take one parameter. Is that fair? No? Yeah, so because this int actually fits in the EAX register here, we actually are not going to get that setup of the stack space for RDI in these cases here. So I guess they don't all take one parameter with an int. So that slide makes that incorrect. Memory address of the result. But the result has to be dealt with regardless. All right. Now, I want to ask this. Does this change anything? So I'm looking at that. The fact that I added these braces. What am I doing now to this value? I'm value initializing it. I am giving it a value. Without those braces, it's a trivial operation. It's going to do nothing with those braces. It has to initialize it before it passes it to the function. And this is the slide that I know that I added earlier that I hope. Hey, it did work. Okay, good. All right. This looked more and more suspicious to me as I was preparing for this talk. Does this code bother anyone? Okay, give me reasons. All right, go back here, Matthew. Am I passing an undefined value? Is that supposed to be a referenced capture? So yeah, let's take my hypothetical implementation of get value. What is the value of S on line 10? 42, junk. What's the other answers? Undefined. Nasal demons. That sounds really bad. You know, I've heard that term over and over again. I don't know who coined it. What's that? Nuclear launch codes. Yes, we don't know, right? Worse than we don't know, we are invoking undefined behavior specifically by accessing an uninitialized value. That's bad. So, out parameters open the door for undefined behavior. That's stronger wording than I've ever used before about out parameters. I like it though. All right. So assignment versus initialization. Optimized build, let's say. Even unoptimized builds in these cases. Little bit extra work in the unoptimized build version. Nope. No, I don't see actually in an unoptimized build version there's any extra work anywhere, is there? Are these all exactly the same regardless of build type? Yeah, I think they are. I'm getting nods over here. I'm going to agree with them. All right, power of triviality. And I still have my asterisks. Int is trivially default constructible and trivially assignable. Does this change things? Yes, but when? In a debug build. In an optimized build, the compiler is going to optimize away this dead store. I think I used those two words correctly. That's the write to the memory location on line 4 that was never read from again, so it will then just write in the same memory location again on line 5. Well, actually, it'll just completely optimize away S altogether, an optimized build in this case. Value reassignment, does it matter, Richard? No, it doesn't matter, because ints are trivially copyable, trivially assignable, trivially destructible. All right. The asterisks. With the optimizer disabled, we still have to deal with these things, setting up stack space, initializing values, calling standard move, even when the types are trivial. So our best practice options are still the best options, okay? Is array trivial? I got lots of it depends answers. Oh, let's do, yes, it is trivial. Okay, no, it is not trivial. It depends. Okay, what does it depend on? The type. Whether or not the type contained is trivial. It's guaranteed to be trivial if the type contained is trivial. So I was playing with this. Now, if you were here on Tuesday and my C++ code smells, I was not very happy with the second option, the get S bad. I'm not even going to ask you which one is supposed to be good or bad because I am good at naming, and you can tell which one's supposed to be good or bad. Now, on the second example, on get S bad, if these were not trivial types, I have to construct them both. I have to move out or copy out the correct parameter or the correct return value, and then I have to destroy whatever was left over. And on the good one, quote, good one, I get the efficiency of just doing return value optimization, right? So I don't have this set up as good as it could be set up, but in an optimized build, these two versions compile to the exact same thing. It does a branch to test whether or not we passed in true or false here, and then it returns either set of values, and in the, quote, bad version, it does the test, and then it returns one of the two efficient values. There's no lifetime for it to have to worry about. Can everything be trivial? What can't be trivial? Polymorphic objects, okay? Heap, at the moment, anyhow, right? Yeah? Any RAI guard. So basically anything with a destructor can't be trivial.
Some of my terminology, any manager or OO-based class or derived thing.
Any manager, OO-based, derivation, anything that's managing resources or dealing in runtime polymorphism effectively. They can't be fully trivial. Anything that's dealing with resources definitely can't be trivially destructible, right? Because that's silly, because that's what destructors are for. Okay. Not everything, obviously, can be trivial. I do want to point out, though, that most things can be made trivial. And I mean or at least trivially destructible. And that is where most of this power comes in. Just for the record, I mean, I've implemented an ARM emulator that is constexpr, and some of you may have seen that project. So I have effectively proven that you can do anything at compile time because I can execute arbitrary ARM code at compile time, right? So QED or something, because I'm like a mathy person. So I've got a container with a value type and a fixed capacity. I can make the underlying data storage an array that has a value type and a capacity. Now, if this value type is an integer, my container is trivial. Trivially destructible, trivially constructible. If I set the current size here, now I have to default the size to 0 because now we're going to start modifying this thing. It's now no longer trivially constructible, but it should be trivially assignable. Oh wait, is standard array trivially assignable? It should be. Yeah, okay. Yeah, so it should be trivially assignable, trivially copyable, not trivially constructible, but still trivially destructible. And then I can add a pushback function, which we can see can be constexpr here, and I can just increment the size and add the new value in. Is that okay? Yeah, I'm not doing any bounds checking at the moment. But then again, the standard library doesn't really do bounds checking anyhow, so it's good, right? Yes, Marshall? Std array does not have a default constructor. Std array has 0 constructors. Yes, it is a work of art once you realize that standard array has no constructors at all. It makes me happy. And basically, we're not allowed to do the same thing they do because their data storage starts with underscores, and we're not allowed to see or touch the underscores. Yeah, so this can be, it's trivially, not trivially constructible because of our size, but the array is not going to stop that because array's constructor is going to do nothing. If there's integers, it's going to be filled with garbage. The issue is bounds checking. Okay. So if we can throw a logic error in here or something, we can throw an exception, we can do bounds checking even in a constexpr function, just as long as that branch is not invoked at compile time. If it is, then we get a compile time error, which makes sense because we just went past the end of our container at compile time, so it sounds like compile time error to me. And then we could do things like assert that the contained type is trivial if we really wanted to like push things here, although it seems that's maybe a bit heavy-handed. Maybe if we really want to do that, we could just assert that it's trivially destructible and trivially assignable or something if we wanted to limit the users of this type, but we don't have to either. No. So the comment was it has to be trivially default constructible for array to be trivially default constructible. Yes. So if we made this an array of strings, which I actually did mean to get to, then this is no longer trivially destructible, and we're going to initialize all of the strings in there. If we had 10 strings, they're all going to be empty strings. It's going to create those objects like it's supposed to. Yeah, and then I can use this, and if you really want to, like I created an array of 1,000 of them just to point out that like because they're ints, it's not like it really has to deal with all 1,000. It just has to put a little bit of code for that exception handler in here, and then the actual code being executed for adding those values back is pretty straightforward. Like this does nothing of any consequence. Comparing to vector, what happens when I do pushback of 1 on vector? Allocates. What happens when I do the second pushback? It's probably going to allocate and copy those values in, and I'll probably have a vector of size 2 or capacity 2. What happens if I do another pushback? Another allocate, another copy, and now I'm going to have a vector of capacity 4, depending, right? Like I'm looking at standard library implementer right in front of me here. Something like that, though. Basic string. Basic string I wanted to mention because, actually, is Brian in the room? No, okay. Basic string is interesting because it is the only container in the standard library that requires that the contained types be trivial. So you can use basic string, and it is going to use small string optimization for a piece of this, but not, I'm not gonna walk through all that. Not for all of it. Okay, so bringing us around to the rule of 0. Rule of 0 says, never define any of the special member functions. With class initializers, this can include the default constructor as well. This likely results in less code and smaller, more efficient compiled code. We're giving the compiler a lot of room to optimize when we're not defining these special members. So, it is trivial. Being trivially destructible and trivially copyable are probably the best things that you can do to write optimizable code. Trivial default constructability is not really our concern. We like initialized values. We like not invoking undefined behavior by reading uninitialized values. Probably, and it doesn't affect our other operations. Follow the rule of 0. And triviality, or understanding triviality, is one of the main keys for writing code that is const-expr friendly. I just threw in one little const-expr keyword in there. In case you didn't realize, that is a const-expr container. I mean, you can just create one of those and use it at compile time and grow it and access the members of it. It doesn't take much work to add the rest of the members that you need. So that is me. We're just about, I'm done, and we have like 5 minutes left. If anyone has any questions, either yell them out or go to a microphone, or I'll run around. Any questions? End of the day on Friday, huh? Oh. Yes? A stood array of non-trivial type that's a length 0. Now, I believe your standard library will prevent you from creating a stood array of length 0 because an array of length 0 is a non-standard extension to the language that many compilers implement, but it's not technically allowed because of address rules. Each object must have its own location in memory. If you have 2 arrays of length 0 side by side, they'd have the same address. You're not allowed to do that. Yes? Oh, the mic's not even on. Just yell. Okay, so small vector, you're saying may be standardized?
There's a paper somewhere, I'm not sure where it's exactly at.
And
it's going to be the same idea. It's a fixed capacity vector.
A fixed capacity vector called small vector, and I think boost static vector is of similar notion. Okay, yes?
Hi, on your container class, I was wondering how it was default constructible because of the size variable which is initialized to 0.
No, yeah, so this is not trivially default constructible because of the initialization of 0. That's what I tried to say, but I may have gotten lost in the double negative somewhere. The data member may be trivially default constructible, but the size member is not.
My confusion is trivial required the class is default constructible?
Yes, no, so this is not going to be fully is trivial. It's going to be potentially trivially default constructible, assignable, movable, copyable, all the things that really matter. All right, thank you, everyone.